All right, we've looked a lot at kind of all around programming up to this point, but we haven't actually talked about how programming happens and what kind of code works on a computer. So that's what we're going to jump into here. So as some background, what we've seen is that computers can do math and basic logic with logic gates. So you've seen how we can do addition and stuff like that. And you've seen how we can look at two binary numbers and say whether they're the same, whether they're different, things like that. But it's hard to see what's just happening there, right? It took us a long time, or maybe you still haven't quite figured it out, looking at that adder to see how that works to add two numbers together. And that's because we're used to dealing with things with lots of abstraction. I say 2 plus 2, and you know, oh, that should equal 4. And you kind of, there's a lot going on here because really it's saying a bunch of things in two groups, and there's 2 in each group, and then combining those groups to get 4. So similarly with computers, we do have layers that we've built on top. So kind of at the lowest layer that we've talked about so far are all of those gates. Then they combine a bunch of those gates into the chip architecture. And so that's like what the computer chip actually is. It's a bunch of gates stuck together so that certain parts of the chip, when you feed stuff into it, it does certain operations automatically, like adding, subtracting, things like that. But to tell which of those parts of the chip to activate, that's where we start looking at machine language. And that's just the ones and zeros that go into the chip. If we kind of look bigger than that, we've got assembly language, and this is kind of the most basic language that still kind of looks like English. It's very simple, and you've got to write a lot of code if you're writing an assembly language to do things, but it is fundamentally just the assembly language gets taken to the computer turns it into machine code, and then feeds it into your chip. But what most of coding is these days is these higher level languages, and that's built on assembly language, and it's basically writing out some things that help make it easier for you to look at it and make sense of it. Because we, as people, don't think in ones and zeros, we think in sentences, and we think with, words and phrases and stuff like that. So let's talk about some of the key things that make up those higher level languages. The first is variables and data types. We use variables because they let us design multi-purpose programs. It would be kind of silly if you, say, wanted to add numbers together. It's nice to have a calculator where you can put, 2 numbers in and get a third number out. It would kind of suck if for any type of addition you wanted to do, if you had to write a program specifically for that. So if I wanted to do 5 plus 10, and I wrote a program that just adds 5 plus 10, that's silly. It's much more useful to have a program that says, give me your 2 numbers and I'll add them together for you. Because then I can use it for 5 plus 10, I can use it for 10 plus 20, I can use it for 30 plus 500. And so this is why we use variables, because they'll say, hey, I don't care what the specific number is in abstract, but when I actually go to run it, tell me what it is, and then I'll plug it in. And there's 3 main types of variables based on what you're trying to store in that variable. The first is what we're used to thinking about like variables. It's a number. So if it's any type of number, decimals, whole numbers, etc., it's still a number. The second type is a Boolean value, and this is true or false. So sometimes we want to know if something is true or false. So we might say, like, are these 2 numbers equal? And the answer is yes or no. And so that would be a Boolean value, is that yes or no, that true or false. The last type of variable or data type that we use is a string. And this is kind of a catch-all everything else, and it's just a list of characters. So if you want to, say, have your name pop up on the computer, you would store it as a string because you don't want it to do any math with your name. You just want it to store each of the letters of your name in that order and then spit them out. So strings can be numbers, but they're not going to be, you can't do math with them. So for example, the book 2001, A Space Odyssey, if you stored the title 2001 for the book, then you would store it as a string probably because you're not wanting to do math with it. You're wanting to keep it as 2001, the title. Next, we've got operators, and those interact with or modify variables. So here's a bunch of examples. You're used to seeing these because they're math things. So equals, this is a little different. This sets a variable. So typically, or I should say, in most languages, these are pretty common things. There's of course going to be places where there's exceptions, but usually if you have an equals sign, it's setting a variable. So if I said x equals 5, it makes x equal to 5. So then if I ask about x later, it says x is 5. Plus and minus, you're used to that, plus and minus. The next line, multiplication and division, same idea. This last one, these are logic operators. So less than, greater than, less than or equal, greater than or equal. They're asking, is this statement true? And it will say true or false. So if you said 5 less than 3, the computer would say this is false. It would check to see if 5 is less than 3, see that they aren't, and it's false. If you instead had put 5 less than 7, it checks to see if that's true, and then tells you true or false. These last two are checking, is it equal? Or is it not equal? And again, these are what are pretty common across most programming languages, but there will be exceptions. The main thing with operators here, you don't need to memorize all these, you don't need to know all these, but just understanding that there are things that we use in a program that work on a variable, or they compare variables, or they do stuff like that. And this is what we call them, is operators. Functions are another concept in programming logic, and they're basically a smaller program that are called from another program, a larger program. And when I say larger and smaller, I don't necessarily mean like how many lines of code it is or how quickly it takes to run. I just mean like kind of nested within. So the whole point of these is it allows programmers to build something once and then reuse it in multiple situations. So maybe I'm trying to write a program that calculates and does statistics, and I'm always wanting to take my data and at one point find the standard deviation. I could write a function that calculates the standard deviation, and then I can just put that in my program, and then anytime I want to calculate the standard deviation, I might have something like standard deviation, and then I plug the data in. And then I don't have to rewrite that whole calculation out here because I've written it, over here somewhere. So the computer takes that data, plugs it in here, brings the output back to my program over here. And the kind of another practical use of this is when it's done well, it makes code much easier to read and understand. Because if you have written it well and you've made it clear and you say this calculates standard deviation, then you don't need to read all the lines of code to see what is all this code doing. You're going, oh, I'm just finding the standard deviation here. I get that. Next, I want to talk about control flow. And these are statements that allow the computer to execute a function or program differently depending on specific situations. So the examples should kind of make this clear. At some point in your program, you might say, if this is true, then do these steps. If this isn't true, do these other steps. And that's what an else statement is. So you might come to a fork in the road and you say, if it's a student working on the computer, send them to this website. If it's a teacher working on the computer, send them to that website. The other example that I've listed here is a while statement, and this basically says, while something is true, do these steps. So maybe you've got a game and it's saying, while the timer is still counting down, the person can still control their player. But then once the countdown ends, they get to stop. Like the game ends. So that's examples of this. They basically say, if certain conditions are met, do something. If other conditions are met, do another thing. And then the last concept I want to introduce here are loops. And these are just a special control flow setup that causes a program to go through a list of steps over and over and over and over again. So that while that I mentioned earlier, like keep doing something while something is true, that's an example of a loop. It'll go through the same steps over and over and over again as long as some condition is true. So an example of this might be a really basic game that's not very fun, but it just counts how long until you press the space bar. Then you might have a while loop that says, while the space bar isn't pressed, add 1 to the timer. So you start off the game and it goes 0, then it goes 1, then it goes 2, then it goes 3, then it goes 4, because the space bar isn't pressed. It keeps going. Say we get up to 1,000, I get bored, I press the space bar, and then it says, oh, the space bars aren't pressed, so stop the loop, and we end and we go to something else. So those are just the basic ideas. As you play around with coding in the next lesson, either in Scratch or starting to learn a language, you'll start to see how these come into play.